Okay, let's get started. Welcome back to the software testing and the quality assurance class. And so this is the last class before the midterm exam. And towards the end of today's class, I will be doing a brief exam review and also go over some of the sample midterm exam questions. Several people asked me about some of the questions. I kind of defer them to later discussion today. Okay, in terms of the course material, we still have a little bit of the things left from chapter 8, and that's about the operational profiles. We kind of talked about the general ideas about operational profiles and the usage-based testing, and particularly the Musa's operational profile. We looked at the ideas, looked at their kind of information sources, the benefits, and all the kind of basic things about their operational profile development for the Musa kind of operational profiles. But we only had kind of a little bit of time left towards the end of last class to discuss the procedures of developing such an operational profile, okay, which we will complete in today's class. So I probably won't spend too much time on that, but we will be going through some examples by following through the Musa procedures. Okay, so let me switch over to the computer now, and okay. So we talked about checklist partitions, and then operational profile, some basic ideas about that, and how do you get to develop the operational profile, and then we kind of stopped by at the point of Musa 1 and Musa 2. We kind of talked about the general idea of Musa 1 and Musa 2. Both those procedures were developed by John Musa, who was with AT&T Bell Labs for many, many years, and who was one of the pioneers and the founder of the software reliability engineering area, research area. Okay, and he particularly worked on some of the practical issues with the implementation and the deployment of the operational profiles, statistical testing, and the reliability engineering in industry. Okay, so we kind of really can benefit a lot from his experience. Okay, so of the two procedures, we kind of talked about both of them, and today what we are going to do is to go through each of the steps in a little bit more detail, and then look at some of the examples. Okay, so in the Musa 1 procedure, okay, which was really outlined in a paper he published some years ago, back in '93, I think. He published this paper, Operational Profiles, and then later on he published another paper and book, and that had another procedure for operational profile development. Both of them are very useful and practical procedures to developing operational profiles, but there is a little bit of confusing part is that those two procedures are quite different, but they both had 5 steps, okay? And so that kind of makes things a little bit confusing, but what we will be looking at now is to look at both of them, because each of them had some kind of a different applicability area. They are good for certain kind of situations. With the what we call the Musa 1, that was the one that he developed first, was a kind of a top-down approach to operational profile development. Okay, and in that, essentially what he proposed for us to follow as a procedure is to first have kind of a very high-level, rough kind of a profile first, and then you try to collect some more information, collect some more information, collect some more information. Each step along the way, collect more information, doing refinement, you get a more detailed profile until the end, you get the so-called low-level operational profiles that can be used directly for testing purposes. In this case, for usage-based statistical testing supported by this operational profile. Okay, so at the top level, it's the customer profile. Okay, and then the next level is the user profile, the system mode, and actually it's a system mode profile. Then it's a functional profile and an operational profile. Okay, so you have 5 profiles along the way, and the first 2 are completely their external view. Okay, and the last 3 is a kind of a gradual transition into internal view about the system operations, so that you can test it. Okay, so going into the functions and the operations, but you can think of them as still somewhat more or less black box view. Okay, although it's kind of with some internal testing focus. Okay, so let's look at each of their steps in a little bit more detail and trace through them with some of the examples. Okay. The first thing that Musa set out to do is to distinguish, kind of separate out their customers from users. So customers are the ones who are responsible for the acquisition of the software. Users are the ones who are actually using the software. Okay, so when you think of this, okay, think of something that we use every day. That we use Blackboard, we use access.smu. Okay, and so when we use those kind of things, who's the customer, who's the user? So the customer actually is the SMU got those things, got their Blackboard, okay, and the course management software and the things, okay, and then within this customer, okay, of course they Blackboard, and they can be in some other universities and some other places, okay. So those different institutions are the customers, okay, and then within the customers we have individual users. For example, that with the Blackboard, we have instructors, okay, we have students, okay, we have graders, okay, we have system administrators, and we have supporting staff, people like Deborah, who's helping us with their distance education support. Okay, and so we do have this kind of a distinction between the customers and users. Okay, so what Musa start out to do is that first you need to kind of identify the customers. Who are the customers? So who are the people who are buying the software? Okay, and then you kind of get a profile about your customers. How many are in this category? How many are that category? And so on and so forth. Okay, so when you look at this is a profile. So you are trying to get some kind of weight assignment or some kind of probability. But this time this may or may not be pure probability, may or may not be purely based on the number of customers. Okay, and so because sometimes there are some other concerns such as the importance and the criticality and kind of influence, some kind of things. Okay, so for example that we may have some of the software that corporations may be using it, government may be using it, and some educational institutions might be using it, and others might be using it. Okay, so this example here, say for example that you have some kind of software database or something that mostly used by corporations and government. Okay, so for example, you would do some kind of accounting and task management. Okay, so lots of government agencies are probably doing that as well as corporations. Okay, so and then educational institutions, we represent a smaller share of the market for that kind of software. So what we end up with is that we have this profile. A profile is basically, remember we look at the definition of profile. A profile is basically a collection of distinct alternatives and then their associated probabilities. Okay, so in this case, we have those 1, 2, 3, 4 types of customers. Okay, and so they are one different from another. Okay, so they are really form a partition of all the possible customers for this software. Okay, so here remember again that we were talking about the partitions, about the basic partition testing, equivalent classes, and this is again the underlying structure is a partition. Okay, but then we also attach probability to it. Okay, so underlying structure is this partition of all the customers into corporations, into government agencies, into educational institutions, and into others. Okay, so they are mutually exclusive and they are collectively exhaustive. Okay, of course we don't allow dual roles here, so that if you say I'm a government corporation, okay, well then we have to kind of either put you in your government or put you in your corporation, okay, and something like that, okay. And you say I'm a for-profit educational institution. Is that a corporation or is that our typical not-for-profit educational institutions? So then we have to make a distinction, okay. So then we have their weight assignment, and so you see there are distinctive choices, and when you add them up, they should add up to 1. So it's the weight assignment or the probability of assignment. Okay, and so this is their top level profile. Okay, and then the next step is that we identify within each of those customers what are the different users, and then we come up with a user profile. Okay, so this is the first step to the second step is actually one of the kind of a critical step, because then second step to third step to fourth step, and kind of follow the same kind of mechanism. So let's work out this one carefully. That's the first to the second step. So the second step is establishing the user profile. We look at the break down the customer groups, the different usage of the user groups. Okay, and then the important thing is that we are looking at the users. They may or may not be the same kind of users across different customers. Okay, so sometimes you may have the identical division of users. Sometimes you may not. Okay, and so we need to identify them. Okay, and so for example that once we do this, we can do the kind of individual user profile within each customer type, and then we try to come up with a comprehensive user profile. Okay, so this is the kind of important step that we need to have a good understanding of. Okay, so for example, then go back to our Blackboard example. We are looking at the SMU. Okay, look at the SMU educational institution. We're using Blackboard. We have several different types of users. We have students, okay. We have instructors. We have graders. Okay, maybe we say, okay, we group graders as the same as the instructors. Okay, so maybe not. Okay, and we have a supporting staff. Supporting staff, maybe you say, I put the administrators and the supporting staff together. We will decide whether we want to group them together or separate them out. Essentially, when you look at those things, is that sometimes if you want to get more detailed information, you probably want to separate them out. Or if they are somewhat similar and you don't really need to distinguish as much, you may group them together. Yes, question?
Can one user be in 2 different groups? Like he's is a grader and T is a student at the same time?
Well, in our case, we are not allowing that, okay, because we are supposed to be looking at the partitions. So you either belong to this or belong to that. And then one way of handling those kind of situations is that have a separate category for that situation, okay. That's oftentimes what people do, have a separate category. It's actually similar to this one here. We have the corporations, the government, education, and other. Other put everything else there, okay? And then in this case, you say someone is a grader and is also a student. And then actually, we can handle it in various different ways. For example, when we are looking at these things for a specific course, this student cannot be both the grader and the student, okay? This individual, okay? So you don't have that conflict. So you look at the individual courses, you don't have that conflict. But if you want to look at the things in general, then you can have a separate category, just putting people with these dual roles as a separate category, okay? And so what we have here is that now we identify the users within each customer group, and then we can, similar to what we did over here, try to come up with a weight assignment with some frequency, with some kind of data collection, some kind of coordination and consolidation. You get this weight assignment. We can get the same kind of weight assignment within each of the customer groups, okay? And so what we end up with is something like this. For example, with the previous one, we look at the companies, the government, education, institutions, and someone else. And then we have the user types. We identify user types. For example, in this case, we have end users, database administrators, programmers, and third-party users. Okay, so we have those in, and then, for example, we look at in companies. In companies, for example, in companies, they may have end users, DBAs, and programmers, but they don't have third party. They don't contract things out. They do everything themselves. Okay, for example, that's the case. Okay, and then what we end up with is that for companies, we have this profile. Okay, so for example, that 80% of them are end users, or 80% of the usage are generated by the end users. Okay. So you look at this, and then their DBA is 2%, and then the programmers is 12%, something like that. Okay, and then you can look at this one for other different customer types. So you can get a user profile for each customer. Okay, which is basically the same as what we did for the customer profile. We collect some information, consolidate some information, and maybe sometimes adjust those weights by the importance, the criticality, and market influence, impact, or whatever kind of reasons you have. So for example, for the government agencies, they have the end users, DBAs, but they don't hire their own programmers, say, for example. They hire someone else, contract things out for people to do. Okay, so they have a third party they're doing things, our government contractors are doing things for them. Okay, and so in the educational institutions, probably, for example, we don't really have our own internal development team to do our own things, so we contract out something. Okay, and so on. So we can come up with those kind of different types of their user profiles for individual customer types. Okay, so what we need to do in the next step is to really try to come up with their so-called consolidated or comprehensive user profile. Okay, what over all the user groups, what is their probability? Okay, how much weight you should assign for each user group. So for example, in some of the user, say, for example, here, look at this programmers versus third party. Okay, in some of groups that they have no representation here at all, but in other groups they do have some representation. And then you have to kind of say what's the overall, how important they are in terms of generating their different kind of operations. Okay, so what you need to do is here now you have this profile, you have this profile, this profile, this profile, and we had this profile before. Essentially, I turn this profile around, and this becomes the weighting factor. See here, the companies 0.5, government agencies 0.4, education 0.05, others 0.05. Okay, so that says that well, if you are a user in the educational institutions and others, you're probably not as really influential as users so in their companies or in the government agencies, because there are more companies and the government agencies as the customers of this product. Okay, so you don't want to have an average of those things. Yeah, average doesn't make sense because some of the customers are much more important than others. Okay, if you're simply averaging them, then you lose the kind of whole idea and the whole essence of their usage-based testing. Okay, so you want to weigh them by their this weighting factor or their customer profile. So essentially, what when you calculate this one is that this 0.8 times 0.5. 0.9 times plus 0.9 times 0.4, 0.9 times 0.05, 0.7 times 0.05, and you get this 0.84. Okay, so this is how you calculate this thing. Okay, and essentially what you have here is that basically you weigh this thing by this factor and weigh this column by this factor, this column by this factor, this column by this factor, and then add them together. Okay, you'll get the comprehensive profile. So, and the result here is that well, you have so as the user profile, your end users will represent 84% of the weight of the usage or something. Okay, and then 2% is by DBAs. And then 10.4% is by the programmers and 3.6% for the third party. Okay, so you can see here, those two columns have a much stronger influence than those other two columns. Okay, and because they have more of the weight for their customer profile associated with it. Okay, so this is a very important step, because this is how you calculate from the previous profile to the next profile. Okay, because what you do here is that you find your individual profile within your customer, and then you weigh them by your customer profile. You get your comprehensive user profile. And the next couple of steps is essentially repeat the same thing. You get your individual system mode profile, okay, for different users, okay, and then you try to find the overall profile, and then you get their so-called functional profile and the operational profile. That's essentially the same thing. Okay, and so the system mode profile is essentially you are looking at the system mode and looking at a collection of operations that's going to be used together. Okay. So this is a really a way. See, we did things from external point of view of customers to users. Now we looking at more from the product view. Okay. Now the first one is just purely from the customer and the user view. Okay. Now we look at it from the product view. When we look at it from the product view, what are the different things that got used together, and so we can identify the functions and the operations associated with this system mode. Okay, And so, for example, that Musa gave the example of some that you have business use mode and personal use mode, attendance mode, system administration mode, maintenance mode, and their probability assignment. Okay, so in a sense is that you get that thing and this thing, and then you can join them together. Okay, you get the customer and the user profile. Now you get the system mode. You can join them together to get your next step. Okay, so for example, that when you look at the things, business use mode and the personal use mode, it's maybe quite different. Okay, so for example, that I was talking about some database product. When the database product is used by business and by individuals, it's probably going to be quite different. Okay, by business, then they have a lot of things related to the large database and a lot of things with their kind of make sure that it's highly dependable, the redundancies and the backup and the recoveries and all those things. For the personal use mode, probably you don't have as much as usage for those kind of things, the large database, backup, recovery, and initialization, and all those things. You have some kind of easy daily operations. Okay, so maybe the functions that's going to be involved are quite different. Okay, so essentially what you need to do here is that you look at those different modes and then assign how many times and how often this one is used by business use mode, personal use mode, attendant mode, system administration mode, maintenance mode. So for example, a lot of systems, they have the kind of maintenance mode. Maintenance mode is that when you don't have as many of the actual users for your system, then that system will go through some kind of maintenance, going clean up the tables, things. Think of operating system, okay? Sometimes they usually need to do some maintenance, such as the garbage collection, because the memory get used and discarded, used and discarded, and so things got kind of scattered all around. And so sometimes you want to make sure that identify where are the garbage and collect them and then clean up, and so they can be used. Okay, so those kind of things are typically done when the normal traffic is way down. And a lot of times that the system administrators schedule some system maintenance at something like 3 a.m., 4 a.m., something like that. That's typically people do it 3 to 7 a.m., something like that. It's after midnight, way after midnight, and before the next morning. And people schedule those kind of tasks. And at that time, your system operations are quite different from the other operations. Okay, so you can identify those things. Okay, and identify those things, and also identify not only the mode, but also the weight assignment. Okay, and then the next step is to look at the functional profile. So the functional profile is essentially the repetition of that what we did with the customer profile and the user profile. Remember that from customer profile to user profile, we look at the customers and then look at the users. Okay, and then with the functional from the system mode to functional is that we look at within each of the system mode how many different high-level functions we have. Okay, and how often are they used? Okay, so how often they are used, and then you can have your the individual functional profile, and then based on the mode, you can get the comprehensive functional profile. Okay, of course you say, oh, what happened with the customer profile and the user profile you identified earlier? Those things will be taken into consideration for your individual functional profile and then later on the user profile, because those different, when you look at these functions, individual functions, they are associated with some system mode generated by some users. You can identify those things, okay? And those users generate this function, that user generates that function, and so on. And so you get the functional profile, okay? So a function in the Musa's terminology is a high-level task or work of the projected system in the requirements. Okay, and you may go through some input domain partitions and the combinations to get your functions. Okay, and you may look at the hardware and the operating system configurations to identify some high-level functions. So this is support this kind of platform, support this kind of hardware. Okay. And sometimes may be based on the environmental variables. So in any case, they are kind of not enough details for you to actually do the testing yet. Okay, but you can identify them from your system requirements. Okay, and you can look at it from the system requirements, from the prototypes, the previous releases, the user manuals, and so on, and try to measure their high-level functions and to try to get their profile. Okay, and so of course when you do the measurement, you are measuring one thing at a time. Okay, you are not measuring everything. That's why after you do the measurement, you get your individual functional profile. But then you look at the individual functional profile for different operational mode, then you really get your comprehensive profile. This is actually one part that there is some problem here, is that when you are doing the testing, you are typically doing testing in one mode and then move on to another mode. You don't do it comprehensively. Okay, so that is one of the things that Musa actually realized this. Okay, because in this one, it's kind of like you are doing this, get a comprehensive operational profile, and then they're doing it together, just kind of with one set of tests for the whole thing. So later on, he realized that really you're testing according to different so-called system mode. Okay, so later on, in his other procedure is actually for each system mode you have a separate operational profile. Okay, so this is a slight difference here. Okay, and in reality, sometimes that you may have the system that this functional mode, the system mode may not be that meaningful. So if that's not so meaningful, you can skip that one. Can go directly from the customer profile, user profile to the functional profile. Because user profile to functional profile, you can look at the users, what kind of functions they are requiring. Okay, and so in the original procedure, there is a little bit of disconnect between this second step, third step, and the fourth, 2, 3, 4. Is that there is a little bit of disconnect. It's a kind of not so well elaborated. Okay. But in actual applications, you may, like in our case study in the book, that case study of one of my former students did the operational profile for software in Lockheed Martin. We actually skipped the system mode because it's kind of all the same. And so now you get your functional profile. The last step is to get refine your functional profile to get your operational profile. So your operational profile will be now for those different kind of operations is you map this high-level functions to low-level operations. Okay, and generally in here again there is this possibility some of the low-level operations support several high-level functions. So that's why you can, again, use the functional profile to as a weight into your operational profile. Okay, and so that's a kind of the same kind of procedure you follow from the user profile, from the customer profile to the user profile. Okay, so that's the basic steps in the Musa operational profile development, the first procedure. Okay, and then in the Musa 2, what essentially he realized that when you are doing testing, particularly for systems with different system mode, you test under individual system mode. Okay, so you don't really need that kind of a system mode profile as much. Okay, but within each of the system mode, you might need individual operational profile. Okay, so that's the kind of thing that it has a one operational profile for each operational mode. So it's basically kind of like the system mode in the previous one. Okay, and then the idea of that is here is try to get some individual steps that you can help you with getting the final operational profile by looking at the different elements involved in developing such an operational profile. Okay, so the first step is to look at who are the initiators of operations. Okay, so for my system, I'm directly dealing with the operations. So who are the ones who will be initiating those operations, will be using our system? So in this case, again, those are the kind of, this is similar to looking at the customers and the users in one step. Okay, look at who are going to be using my system. Okay, and then the next step is in the Musa 2 said is that you determine whether you use a tabular or use a graphical representation. Okay, a tabular representation is like a table. Okay, the thing is that the graphical representation in Musa's terminology is actually has a special meaning. It's not just you have a bar graph, that's a graphical representation, because a bar graph is equivalent to a table, right? Okay, you can, anything that you can have that a bar graph, you can have a table, so that's still called a tabular. So graphical representation is, in the Musa's, Musa 2 terminology, is actually the tree structure representation, okay? The graphical representation is a tree structure, so that you can divide the overall operation into stages. When you divide the overall operation into stages, then you have a kind of a tree structure to it. Okay. And then the next step is that you come up with the operations list. What are the operations? So basically, you look at the initiators. What do you use? You use A, B, and X. What do you use? You use B, X, and Y. What do you use? You use A, B, X, and Y. What do you use? You use X, Y, and Z. Okay, so you come up with this list. Okay, consolidate them. Okay, and then you try to collect the information, do the measurement, so determine the occurrence rate, and the last basically say how often it occurs. You can do it over a day, over a month, over whatever kind of period that you define. And then you collect those things, how many times this occurred this many times, and then I try to normalize them, okay, and get the result, okay. So let's look at each step in a little bit and look at some examples, okay. So initiators of the operations, okay, who are the users, okay, and not only the human users, but other hardware, software, network, and all the non-human users as well. And you need to consolidate across organizations or customer types. So it's kind of, we consolidate all those customer profile and the user profile into one step, okay, but without assigning the probabilities, okay. And then tabular and the graphical representation is, we talked about, is actually here. Tabular representation we have seen before is something like this. All those things are the so-called tabular representations. Okay, so we have a table and then we have this graph. They are both tabular representations. A graphical representation in this Musa terminology is something like this. For example, that you come up with something that had multiple decision points. So the completed operation will involve several steps. Okay, that is what Musa called the graphical representation. Okay, and then you look at the initiators and then look at their operations and consolidate them. and then you measure them, and then you determine the probability. So we can look at this example and come up, for example, this is an example with their web usage, okay? Or you can think of browser usage. So just imagine that Microsoft, who's having the Internet Explorer, or the Mozilla has a Firefox, or the Apple has a Safari, or some other things, okay? Google Chrome or something. And each of the browsers, they want to look at how the different users are using their browsers to navigate the web, okay? So we can think here, then people always have a startup and then have some other usage, okay? And so we can just think of the simplified version, that you just have a startup and have some follow-up usage, and that's it, okay? So when people start up, they may have their browser customized, or they may have their browser just use the default, okay? So for example, that we measure this many people and their usage of the browser, so that we say, okay, we found out, we measured, collected 1,000 kind of such user instances, okay? We found that 200 of them use the default, okay? And 800 of them used their customized. They customize the browser with their own security settings, so their own bookmarks, so their own whatever kind of things, okay, cookies and other things, okay? And so we got this. And then after that, you look at, you will be navigating through the web, okay? When you look at the navigating through the web, you say, okay, am I following the embedded links only, okay? Or I'm using some bookmarked, okay? Or I'm using some kind of thing typed and some kind of a mixture. See here, we have three kind of linked, bookmarked, and a mixture. So if you do have something together, we put them together as a separate entry. That's kind of like your last question about when you have something has multiple purposes and multiple roles, then you isolate that out and to form a new subcategory. Okay, so we have those people who exclusively use the embedded links, exclusively using the bookmarks, or they have a mixture. Okay, so we can have this. Okay, and so we have the linked, bookmarked, and the mixture, linked, bookmarked, and a mixture. So, for example, over here, about the people who are using the default, they are probably not very likely to do a lot of their own things, because they didn't customize the things. Okay, so they are not using much of the bookmarks and the things. And so you can have this number, and then you have a different number. And so what you end up with is that you can normalize this thing. You first look at their initiators. Okay, there are different web users. So now you know the initiators, and so that's just one category. And then you look at the determinant on their tabular versus graphical representation. In this case, graphical representation seems to be more meaningful. Okay, so you say, well, I'm going to use a graphical representation. And then you look at their, what are the operations? Okay, operations, so they use the default, they use linked, they use mixture and things. So you organize this in your graphical representation. Then the next step is to collect those instances. I collect over 1,000 instances, and then how many going this way, how many going this way. Among this 800, how many going this way, and this way. Among the 200, how many going this way, and going this way. Okay, and then I normalize them. I got this 0.2, 0.8, 0.8, 0.15, this thing, and so on. So I got this so-called their operational profile in the graphical representation. Okay, And one of the interesting things is that with this graphical representation, it's a tree structure. One nice thing about tree structure is that you can kind of flatten out the tree. You can do the kind of leaf traversal, flatten out the tree. And so, for example, what's the probability of this versus this is a 0.2 versus 0.8. What's the probability of this, and they are divided this way. And what's the probability of following this and this is basically this probability multiplied by this probability, right? You get this one. So you can actually enumerate out all the paths from the root to each of the leaf node. And you get this operational sequence and the probability. Actually, when you look at over here, operational sequence and the probability here, that is like what? Like the tabular representation. You can flatten the graphical representation out into the tabular representation. Okay, that is why sometimes that when you look at the things that you can flatten things out, and then that's also why we, even with the tree structure, we still consider it as something that with the kind of flat structure, because you have this special property. Okay, but once you have loops, you cannot flatten it out, because you can go through the loop 0 times, 1 times, 2 times, and then potentially infinite number of times. So the number of choices will be, instead of a finite number, you will have a potentially infinite number of choices. Okay. So that's the example of this operational profile development. Okay, for MUSA 1 and MUSA 2. Okay. So the generic steps, they are somewhat different, although they each have 5 steps. But when you compare them, they each may have their own advantages and disadvantages. Okay, if you have a lot of operations, a lot of customers, then also customers, users, and a lot of operations, then MUSA 1 is probably going to help you a lot more. Okay, but if it's a simpler situation, then probably MUSA 2 is going to be useful, and because it has a more refined individual steps, easier to use. Okay, so you have to look at what's the kind of a specific situation you have. Okay, and then look at what kind of choice you want to have. Okay, and the rest of the chapter is really a case study from one of my former students who was in the class and did that as a part of a project. And he did such a good job, and I asked him whether he want to try to make that into a paper, and so he did so, and I helped him with the paper and with some of the background and the ideas as well. And then we submit the paper to the IEEE International Symposium on Software Reliability Engineering, which is actually a very good, prestigious conference. And we received the Best Paper Award in that. Okay, so I'm very proud of this one of my former students. Okay, and I'm not going into the details here, and you can read this, but I want to highlight a few things. For example, in this one, one of the things that there are lots of practical things that when you really run into these things, you will have to deal with. For example, he started with interviewing the managers and to get the customer who to contact, and then send out the questionnaire and get out the result. Okay, and in the step, and he looked at the customer profiles, and then all the customers are similar, and so kind of looked at them but skipped. Okay, and then look at the user profiles, and the user profile, they have the different users of this system, but they may, although they have a frequency of usage is one way, but their kind of importance is different. So he kind of come up with a comprehensive weighting that is taking care of both the marketing concerns and the frequency of usage. Okay, and Then the result presentation part is also interesting because when you get the individual numbers, sometimes the people don't really care that much about the individual numbers. They care about the range. Okay, so in his case, he grouped those different operations into the group of usage that are highly used, that medium high, medium low to low usage, and so they kind of group into those 4 categories, and they reviewed the things, and they found out they actually there were some surprises. Some of the things that they think people will be using more, people were not. Okay, so that points out to some discrepancies in their testing procedure, and so they can make adjustment and improvement. Okay, so that's kind of their case study. I'm not going to go through. You can read it through it in their book yourself. Okay, there are also some discussion about some other operational profiles, because the thing is that with the Musa operational profiles, we can only represent kind of flat or at most the tree structure things, but we cannot represent the complex operations and their usage probabilities. Okay, for that we will have to wait until after midterm when we look at the finance state machines and how do you attach their usage information to the finance state machines. Okay. So that's all I want to talk about for this chapter, operational profile. Question there?
Is Musa operational profile the only operation profile, or is
there's another one we will talk about after midterm exam. That's the Markov operational profile.
So the one you're showing with the file types.
All those things we call this the Musa operational profiles.
Okay. So
Yeah.
that's not a Musa 1 or Musa 2. That's
Musa 1 and Musa 2 are just the procedures.
okay.
Okay. And the operational profile, all the flat operational profiles are generally named the Musa operational profile because Musa initially proposed those. Okay, let's take a break, and when we come back, I'll move on to the next topic.
So they're like 15 marks each.
No, you just 12.5. So no. I missed. So I got plus 10. So you just 12.5, 25, 2.3. And
How many questions are there?
like 7 legit questions and 1 question the bonus. So he puts it back 110.
Yeah. So this one
I got up the pay scale. $1 a week, really? Nah, I'm okay.
no, this one like I really want to try because I studied for 5 subjects.
Quizzes at the end of the day, I'm going to be $25.
Maybe he was talking about
So we need to do, when he asked for example, we need to do these two.
and that's that.
I don't know, I just looked at that.
You know,
He didn't ask for Musa, he asked for this one. Whatever it is. He didn't ask for Musa. That's operating. That's an opinion. No Musa, no Musa whatsoever. So this is a regular operation. Then Musa 1 and Musa 2.
I get off at 5.
Yeah, that's fine. You get a good marks.
Oh, so which one?
The best is 10.
Okay.
I don't know.
But you know, I can do all your questions, you're gonna be there after.
You can just directly email it to them.
Oh, I do.
That's my first two.
Because I did.
That's my first two answers.
I just tried like 34 and
This is why we shot
Oh.
Three aspects of
No, that's the
the
second part.
Yeah.
First part is a summary, and also he asked in the first part there is two parts, summary and another thing is like whom you aspire to become.
There's only one
No, there is no two parts. There's a two parts. There's like part one is a two-part inside, and part two is a two-part inside.
Am I missing something?
shortest answer.
Yeah, that's what I got.
Today he's going to take case study like
Wow.
5 or 6.
Yeah, that's right. I'm positive this time. Even last time I was positive.
Yeah.
We'll go back and show
Mine was too. So.
Who is taking first?
He has a monster energy.
We had
He has all the energy.
I don't have my laptop.
That's okay. You can
No, the thing happened. I went home.
I'm like, I just.
When I started living,
I don't know.
I got a flat tire.
I'm just glad
That's
I
why
got
the
the
flat-
first machine up and running, now I got to
Just now.
run against it. So,
Can you open it?
I don't have the hardware. You know, look at the next one.
This is the one.
Like, I'm not behind in food, that's my. If it's not free, I'm not doing it.
What's your black?
Answers are-
Black.
No, it's the same.
Sorry.
The 34 from the answer. That part, what's the 45?
Yeah, so one part is a
What kind of leader
two
do you
stop.
aspire?
One part is a two stop.
I have.
There are two
No,
parts.
it's the same thing.
Yeah,
So, Mona, what is your impression of this? So start with
Because I was really watching my phone. What did you say?
So what kind of leader do you inspire to become? What kind of leader do you? The first part is 30 words.
So this both of this leaders.
No.
I mean, what is this strategy that we should like to be? And this is the same thing that you're answering over here. What kind of leaders you aspire?
No, this is not full stop. And
It's just one thing. And
yeah,
then
I did 30 words and then I put another page for this one. What kind of leader do you inspire? I give a reason why I want to become leader.
somebody
Don't copy me. I seriously put Gandhi. Put it on this.
he will say in all of
What
us.
is he-
It
what
will-
does he
it will
say?
be following
What-
in my
so
techniques.
He's a charismatic leader.
Do you think Gandhi is charismatic?
Not only, you find it.
He's
I
influential.
swear to God, I put Gandhi.
And then he thinks also like influential.
I mean, he was a people oriented.
Gandhi also is.
No, he was one of the only principles. He was a people oriented. He was listening to everyone, but he was doing what he wanted.
I remember when I was getting my phone.
America was different. He was listening and he was implementing.
Anyway, so this is the second part.
And second part is the
Three
two.
aspects.
Yeah.
No, it's not two.
Yeah, there's the first part and how does it
Yeah, so this is the second part, so that is 750 words.
altogether 750 words?
Yeah, this is altogether 750 words.
And did you try to do therapy style?
No man.
It took me like 2 hours to do this style.
Yeah, I know it's painful.
Yeah, I asked him.
Can you do it in Word or something? Or
Yeah, you can do it in Word.
I mean, you just say select all and then say like,
No, you can't. No, it's not like hangover style. It's not that style. It's about like particular difference between the inches. It has to be between 2 space. Every new chapter has like 2 inch from the top. There are so many stuff. But it's weird. There is a 20-minute video on YouTube how to do that.
I'm gonna do like
Basically Sunday. It was Monday. We need to study for this test too. Yeah, but you can study on Wednesday morning.
can you give the test taker a distance?
So you are coming here? Yeah. Oh, I'll copy from you.
Look at him. He's going
There are one question.
first question and message. Then short discussion. Third one is problem.
One is theory. That's what I told you. I don't know what to study.
And after finish up this course.
You start writing, you keep on thinking. It's never ending.
Because you have to see theories, correlate them with your application.
So thing is, I put like 5 hours, 2 hours in that, 3 hours in my response.
We are essentially your ideas and theories.
Yeah, but you need to let like you last month. You don't need to write much. All you need to write is like how they are related.
See,
you're not
pick
gonna
3 aspects, which is
So you need
ideas
to
or
give-
theories.
so
They
there-
come
there-
from your 30 words, right?
No, they can be. I mean, you can, but you need to give an example, right? Who was that kind of? Let's say you
I mean, you basically substantiate it with some evidence.
you pick one theory from Oxford and so you try to discuss what it is. Example, who was Oxford and
That is fine, but I'm just thinking like the ideas and theories come from the 30 words,
yeah.
right? Pick any 3 aspects, they might come from your 30 words.
Thing is, my first 30 was I went to like I wrote anything. When I read
I sent him a question right to
my experience, but we didn't follow any. Much about all I find about what's
So I can do one like for tonight.
Okay, let's go back to our class. So what we have left before the midterm exam is we still have one big testing technique that we haven't really discussed in detail. So I want to spend the next remainder of today's class, except the last part for the exam review, to discuss this one. Okay. I'm going to actually rely more on the examples and then to looking at this testing technique rather than exactly follow the slides. Okay, so what we can do here is that we can start from this example sketch we had before, and to work from there. Okay, so let's switch over to this desk camera. Okay, I think I need to zoom out a little bit so I can cover the whole pad. Okay, so we were talking about this partition testing and then checklist to partition. Partition is basically has a nice property of it's mutually exclusive and collectively exhaustive. Okay, and we looked at the basic partition testing. We try to sample from each of the things. Okay, so for example, that we can sample 1 point from here, 1 point from here, 1 point from here, 1 point here, 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 and so on. Okay, and then what we end up with is this kind of uniform sampling of the basic partition coverage. Okay, but then we noticed that not every partition is equally important, and not every partition and not every place is equally likely to be involved in some kind of defect, okay, or related to some defect, okay. So we noticed that, well, if we use this much more often, we should test it more often, okay. So for example, in this one, I can build an operational profile, divide this into these operations A, B, C, D, E, and F, and then operations A, the operations that belong to the 8th category will have a 0.8 probability, and this one have a 0.1 probability, and so on and so forth. Okay, so I can do this. I can go through this thing, go through my Musa operational profile, and get this kind of a problem solved, addressed. Okay, at least. Then we also notice that not everything is equally likely to be linked to some defects. Okay, so for example, one of the things that people noticed is that, particularly in this case, we are doing the partitions. When you are doing the partitions, if you have a point here, does it belong to A or does it belong to B? Well, that's oftentimes the contention there. Okay, and actually, that is precisely the problem with the partition. If you define the partition, you want to make sure it's mutually exclusive and collectively exhaustive. So every point belongs to one and only one of the subdomains. Okay, so the boundaries are the ones that you have to decide belongs to where. Okay, so that's where when you make the decision, that decision may be depends on how you are exactly making that decision. That may be different. Okay, so for example, that now let's look at some simple 1D and 2D example, and then start from there. Okay, so for example, if you are looking at a line, this is x. Okay, and then you say I have two regions. A region is x greater than or equal to 0. B region is x less than 0. Okay. In this case, the whole thing can be divided into two parts, right? And into this A and B. Okay, so you say here's 0, and then this one is A, this one is B. But then where is this 0? 0 belong to A or belong to B? In this case, we follow this inequality. It's greater than or equal to 0. So we say this one belongs to A. Okay, and this one does not include this point. Okay, so this is usually we kind of try to draw something to say, okay, whether it's inclusive or not inclusive. Okay, then you can have some other things. Okay, for example, when you go to the 2 dimensions, okay, you have a, say, here you have a circle. Okay, you have a circle here. Okay, when you have a circle, you say anything inside the circle and outside of the circle. There's something that you can represent. Okay, and then, for example, in this case, you say you have to decide everything on the boundary. does it belong to A or belong to B? Okay. If it's say it belong to A, then you say, okay, I can shade it on this side. So everything inside here belong to A. Okay. I can shade it some way and to indicate whether it belongs to this side or it belongs to this side. Kind of like I can use the square bracket to be inclusive, and then this bracket will be exclusive. Okay, so I can shade them. I can adopt a convention. So, and the typical convention we use here is that on the shaded side is that it belongs. Okay, and so it's then in this case that we say, okay, everything on the boundary belongs to A. Okay, then every on the boundary is not belonging to B. Then what I can do is that well, then I can look at this thing, and then I can, when I do the test, I can test accordingly. Okay, so in general, when you look at this kind of situations with boundary testing, okay, typically people look at what's your variable. Okay, so you look at the variable here. Here we have an x variable, we have a y variable. Okay, right? And here we only have the x variable. Okay, and then we can divide this, say, for example, into some further bracket and so on and so forth. Okay, so we divided this as A, B, C, D, for example, E over here. So it's no longer this equation anymore. Okay, so one of the things that people say, oh, okay, when you divide things into these different segments, different boundaries and things, why don't you look at the variable and what's the maximum value and the minimum value and test them? So that's one of the kind of very intuitive kind of notion about boundary testing. Look at the variable values and how far can you go, how high can you go, how low can you go, and then you can test it accordingly. Okay. So in this case, then what you have there is that, say, for example, I'm testing A. A is here, between 0 and, say, for example, 100. Okay, between 0 and 100. I want to test it. So what are my boundaries? My boundary is 0 and 100. Okay, so one of the commonly used strategy is to look at this variables involved in this any input domain definition. Look at the variables, and then try to push the boundary on the variable. Okay. When you try to push the boundary on the variables, then on each of the variable, it's a numerical variable here. We are talking about the numerical variables. So here is a minimal for this A, right? Here's a max for this A. Okay. So when you are trying to do this, what you're trying to do is that, well, if this, I have a minimal and I have maximal. When I do the test, I want to push the boundary. And inside the boundary is probably okay because I already sampled some internal point. Typically, with partitions, I need to do the sampling. Okay, so I say, let me push the boundary, push out of the boundary, and see if it still works or not working. Okay, if it's still handled by your system correctly or incorrectly. Okay, so when I push the boundary, so here, when I push the boundary, I push it under and over. Okay. So we have under something under the minimal, and then we push it this way. We push it over the max. Okay, so under the minimal and over the max. Okay, so we can push each of the thing under the minimal or over the max. That's a push outside of the boundary, right? So that is essentially one of the first proposed testing strategy for this kind of boundary problems. Okay, look at the kind of extreme point and the push over the boundary. Okay, so in one dimension, you say I can do this. Okay, and then in two dimensions, how do I do it? Then I look at each of the variable involved. and I push it under or over. Okay, and then when I do that, for each of the variable, I have a minimal, max, under, over. Okay, under, minimal, max, over. For another variable, I also have a under, minimal, max, over. Because the test point is involving those two variables, I have to combine them, right? So if I do this, I have to combine the boundaries, okay, for each dimension. That gave us the name of EPC, which stands for extreme point combination. Okay, so that's one of the earliest strategies that people proposed and people start to use for boundary testing. Well, unfortunate part of that is EPC strategy works sometimes, but not working all the time. And in some cases, it can be a really bad strategy. Okay, so let's look at some of the examples here. Okay, let's look at the EPC strategy for this one. Okay, for this region A. If I do the extreme point combination strategy, one dimension, I don't have to combine with another variable, so I just have those 4 testing points. Okay, so I have under here. This is my under point. This is my minimal point. Under. This is my max, and then I have another one. It's the over point. So I have this 4 points to test the things. Okay. When I test the things, essentially I'm testing whether something is on the boundary or not on the boundary, and the things where you made a mistake about these things. Okay? So what kind of mistakes can you make on the boundaries? It should be on the boundary. It's not on the boundary. Okay. Should be open. It's closed. Closed means that is inclusive. Open means that's exclusive. Okay. Or maybe sometimes the boundary got moved a little bit. Those are the typical problems with the boundaries. Okay, so let's say, can you detect those kind of problems with this extreme point combination kind of strategy? Say, for example, here we look at this A. We supposed to have a closed boundary on both ends, on the minimal end and on the maximum end. Okay, then what I'm looking at here is that then when I test those points, when I have the minimal is tested, when I test it, I'll discover that it is belonging to A. Okay, so that's fine. And then I test this maximal. Let's say it belongs to A. That's fine. Okay, and then if it's implemented correctly, when I do the under point, it will not be treated as A. It will be treated as, in this case, C. So if I can confirm it's treated as C, I'm okay. On the over point, if I can confirm it's not treated as A, it's treated as B, I'm okay. So I confirm that this boundary is working correctly. Okay. What if I have made a mistake? So let's use the red pen for a mistake. Okay. Instead of this, I made a mistake of something like this. Instead of the inclusive boundary for A, I made them exclusive. If I made them exclusive, then let's say if those 4 points will, some of those 4 points will help me detect that problem. Well, in this case, if you have a closure problem, this is a closure problem. You are open or closed. That minimal is no longer belong to A. Minimal is now belongs to C or belongs to someone else. So you are not be treated as A. So I can detect that problem by this A point. Okay. This minimal point. I'm sorry, not the A point. I can detect the closure problem by this max point. If it's supposed to be closed, now it's implemented as open. I can detect that problem. Okay? So I can detect those problems by the minimum and the max if there's a closure problem. Okay, so it seems to be so far so good. Okay. Now let's look at some of the other situations. What if your boundary gets shifted a little bit? Okay. So now we are still looking at this A. Let's draw this out. So this is A and compared to something else. Okay. Say for example, instead of over here, you shift this a little bit. This is your actual. This is your intended or specified or the correct one. This is the actual that maybe you have some problem. See if you can detect that kind of a problem. Okay. So now let's look at our extreme point combination strategy. We still have our 4 point. Under, minimal, max, and over. Okay. And the thing is that where do you put this over? So maybe you put it here or put it there. Let's decide this later on. Okay. So for example, over here, this one, those 2 points have nothing to do with that boundary, so you don't expect them to detect this problem. Now you look at this one. If this one is pushed over this way, what we will see here, this one is you implemented this way instead of this way. Okay, this one will become an interior point instead of a boundary point. Well, it still receives A processing, so you cannot really tell. Okay, and this one, instead of receiving we call this a C. This let me see. Oh, I called this a B. I'm sorry. I call this a C. Okay, A, B, C. Okay. Instead of this point, instead of belonging to B, now it belongs to A. So we can detect that problem. Okay, by this one. We cannot detect that problem by this one. So what that's saying is that when we choose the over point and when we choose the under point, we have to choose the point very close to the boundary. So any small amount of boundary movement, we will be able to detect. So that's the requirement for the under and over point. Okay, small enough to detect any problems that you're moving the boundary. Okay, so you can detect that problem. Okay, and now let's look at if you move, instead of moving that way, you move this way. The boundary moved this way. If you move this way, then what happen is that now my original point here originally belongs to A. Now it will no longer belong to A. It belongs to B. So my boundary point will help detect that problem. So in this case, actually, it's good. Okay, so this kind of extreme point combination works for this kind of case. Okay, but it may not work for every case. For example, we have the B here. B is something like this. Okay, with B, what we had here. So let's magnify B out. Okay, region B is like this. This is X. The B is something like, see here, it's open for the minimal and closed down for the maximal. Okay. This is my B here. So if I do the extreme point combination, what I'm going to do is that I have under, minimal, max, over. These 4 points, right? Under, minimal, max, over. And then I may be able to push things in and out a little bit and say, for example, over here, I might be, instead of implementing this way, I might be implementing over here. My implemented minimal is actually bigger than my original, the intended or correct minimal. Okay. In this case, you see, originally, this one belongs to A. This one also belongs to A. And after I do this, both of them still belong to A. So this one, we cannot tell. We cannot detect a problem here. Okay? So we cannot detect a problem here. That says that's kind of blindly trusting this pushing the boundaries may not work for every case. Okay? But in this case, actually, if you can modify your strategy a little bit, instead of putting the point here, you put in the point inside, then it will detect the problem. Okay? You put a point inside close enough to the boundary, then whenever you move this way, it will, if you are close enough, it will move past this point, and this point originally belongs to B, now belongs to A. You will detect that problem, right? So if I change this one around, it will work. Okay. So the thing, what I'm saying here is that, well, you may be able to change this strategy a little bit, and then can come up with a strategy that can detect the problem. Okay. So this is in one dimension. When we can look at it in the two dimension, yes.
Could you give an example using maybe an input text box, not numerical box with an upper and lower boundary?
Yeah, we will be looking at some, not just one dimensions, and then look at so now let's look at the 2 dimensions. We had this picture here. We said this circle here. Well, if you had this circle, it's going to be a disaster. Okay, and if you had some 2-dimensional things, is a kind of a perfectly aligned grid, then it's probably not too bad. Okay, we call this A, B, C, D, E, F, for example. When you have something like this, A, B, C, D, E, F, okay, then when you look at the X and the Y, X and the Y here, what's the minimal? Let's just consider A first. What's the minimal for X within A is this, right? What's the maximum is this. What's the minimum of Y here? What's the maximum here? So if you identify here, is this one will be under, minimal, max, and over. Okay, we can use a small m and a big M or something like that. So here you have this one is this under, minimal, max, over. When you combine them, because each point will have an x value and a y value, you will combine the boundary values. So essentially what you end up with will be this point. So there's a 4 times 4 equal to 16. Yeah. So what you end up with is you're testing the corners. Okay, in this case. Right? You're testing the corners. So you have your test to testing your corners. In this case, it's not too bad. You're testing the corners. That's kind of combine this boundary and this boundary together, testing the corners. Okay. But if you look at this thing over here, what's the minimum of x all the way here, right? Maximum of x all the way here. Minimum of y is all the way down here. Maximum of y is all the way down here, up here. Okay. So essentially, you say, okay, this is my minimal x. This is my maximal x. This is my minimal y. This is my maximal y. If I do the combination, it will be this, 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 and this. 16 points. This 16 points all belongs to B, has nothing to do with the boundary. So in this case, this is a really lousy strategy. You spend 16 tests testing nothing, basically. Basically 16 tests is all sampling something from B. That's not what you intended to do. Okay, so what you really intend to do is to really find something here and find something here so that you can test. Okay, the things. Say, for example, you have here. You have this point and this point. Then let's look at the problems you might have. The problem is that you may have the closure problem, you may have boundary shift, and may have some other problems. Okay, and then if you have closure problem, it's supposed to be belonging to A. It's not belonging to A. Then my boundary point will detect it, right? Because the boundary point, if it's closed, it belongs to A. If it's implemented not as closed, it will not belong to A. So I can detect that problem. Okay? And then we can look at the boundary movement, shift in and out a little bit. If you shift this in, let's now say you have a problem. Problem, you shift this in a little bit. Shrink it in or move it in or some way. This boundary is moved a little bit. If it's moved a little bit, then what that means is that your new boundary will be something like this, right? If your new boundary is something like this, then this one will be falling outside. You can use this one to detect that this no longer belong to A, so we can detect the problem. Okay. What if you move this way? If you move this way, then this point originally belonged to B. If it's close enough to the boundary, you will move past that point. And then that point will now belong to A. So that's not the correct answer. So you detect the problem. You see? So by this pair, you will be able to detect the problem. Okay? And so the thing is with boundary testing is the basic idea is that not to look for the individual variable, extremes, or the individual variable value extremes, but looking at really the boundary points. How do you define the boundary points? And then try to come up with your strategy to do it. Okay, the strategy we come up with, actually, in the book we discussed this. They were originally came up from Lee White and his student from Ohio State University. Okay, so they say, okay, you need to define the boundary, and then you need to have one off point. Okay, so you need some so-called on point, some off point for your boundary. Okay, so you try to have the points on the boundary and some points off the boundary to help you test. Originally, they said, okay, for a two-dimensional boundary, if it's a linear boundary, how many points decide the line on a two-dimensional space? You need 2 points to draw a line through it, to define a line. Okay? On a three-dimensional space, you need 3 points to define a surface to cut this three-dimensional space into 2 halves. Okay? So, depending on the dimensions, you need n. If you have n-dimensional space, you need n point to define a boundary. Okay? So you have n point, and you have 1 point. So that's called the n by 1 strategy. Okay, and typically we call it a weak n by 1 strategy. I will explain the weak part later. Okay, so for example, now we have A and B here. This is a two-dimensional space. I have A is something like this. B is something, for example, something like this. I have A and B here. The boundary between A and B is over here. And say, for example, it's closed on A, open on B. Okay, so this is the boundary. So what essentially with the boundary testing strategy is that I need to confirm the exact boundary. And then I can put something off the boundary to test where one domain ends, another domain starts. Okay, so in this case, I need this one. This is the on point here. This is the one on point and the two on points. Okay. I also need another point that exactly where one domain ends, another domain starts. In this case, I need to find my off points here. Okay. Why I choose the off point outside here, outside of A, inside of B? Well, the thing is that if it's inside A, it's not going to help because it will receive the same processing as the on points. Okay, it's not adding any new information. Okay, and if I put it outside of A, put it inside B, it's actually going to help me generate some new information. So, for example, that if I have a boundary closure problem, my on points will detect it because it's originally supposed to belong to A. If you have a closure problem, now it's no longer belong to A. I can use my on points to detect this kind of a closure problem. Okay. What if I have a boundary that got shifted a little bit? If it shifted this way, well, this off point will catch it. Okay. So this way, that's the problem detected by off point. If you shift this way, right? So the off point initially it should belong to B. If you shift this way, if it's close enough, you'll shift past this off point. Okay. What about if you shift that way? When you shift this boundary that way, essentially those on points will falling off the boundary, become the outside point. So shift that way, this problem can be detected by this on points. Okay, so I can solve all those problems. Okay, so essentially what I need to do is that to find the boundary and then find my on points and the off points. That solves my boundary testing problems. Okay. And one thing that people notice here is that if you're looking at those kind of things, why do you need two on points? If you have one on points, probably you can do the same thing, right? Say instead of have the n on points, if I have just one on points, you see here the problem with the boundary closure problem I can detect because the two on points they will behave the same way as the one on points when the closure changes. Okay, so I can detect the problem. And if it's moving this way, my off point will detect the problem. Moving that way, my single on point will also detect the problem, right? So that's something noticed by a researcher called Elaine Wyuker and her student. And they noticed that in this n/1 strategy, most of the times it's really redundant. Instead of use n on point and one off point, why don't you use one by one? One on and one off. That will be enough. Well, most of the cases, it will be enough. But it's not really considering some of other situations. Okay, and the other situation is really when you look at this boundary, they may kind of shift a little bit, but sometimes the boundary may be tilted a little bit. When the boundary gets tilted, your single on point may not detect the problem at all. Okay, so for example, this is again between A and B. Let's say this is A, this is B. Okay, and in my actual implementation, it's got tilted a little bit, becomes this way. Okay, this is my actual implementation. This is the color. Okay, so suppose you picked your on and off point here and here. If you pick the on and the off point here and here, you will not be able to detect the problem because the on point is still on, off point is still off after this mistake. You will not be able to detect this problem. But if you did have the n by 1 strategy, then you will have n on and 1 off. Doesn't matter your other on point, say, so this is 1 by 1, so cannot detect this problem, right? But if you have the n by 1 strategy, then say, for example, your other on point is here. I should use the green one. Then this one will be, instead of, say, originally on the point, now it will be falling off the point, right? If your point is over here, another on point, if this is a pair, then this one, instead of originally on the boundary, now it's going to be inside the boundary, okay? And this one, the thing is that, of course, here, when you tilt it, and if your off point is somewhere near the center, when you tilt it, it will tilt past it. Okay, so you tilt right here, you will tilt past it. Okay, and so essentially, when you look at it, when you have the n by 1 strategy, okay, you can draw this out. Say, for example, here, we can draw this out again. Is a 2 on and 1 off. Off will be near the center of those 2 points. Okay, you can look at where it tilts, and can you catch the problem? If it tilts here, okay, say we still have this A, and this is a B. Okay, so let's look at where can you tilt, and where can you catch the problem. If you tilt this way, the on point will fall off, so we can detect this problem. If you tilt this way, the off point will be inside. You can detect the problem. Okay, so when you tilt anywhere along this side, it's this way. Tilt anywhere here, tilt this way, the on point will fall off. You can detect the problem. Tilt this way, the off point will become the part of A. You will detect this problem. You can do it up to this point. Up to this point, you can use the same argument. So the other on point or the off point will detect it. What if you tilt in the middle? If you tilt in the middle, still okay. Tilt in the middle, one of the on point will be falling off. Okay. Actually, one of the on point will falling out, and one will be inside. Inside you cannot detect, but the one falling out you can detect. So it doesn't matter. You tilt in this segment, tilt in this segment, or tilt on those points. Anywhere you have a tilt, you can detect the problem. Okay. So that's why this weak n by 1 strategy is still, in terms of the ability to detect the problems, is better than 1 by 1 strategy, but only at that kind of central point is where you have exact tilt on the single on point. That's the only case that makes a big difference. All the other cases, the 1 by 1 strategy is really a good compromise by reducing the number of test points, but not reducing the problem detecting ability by much. Okay, so those are the 3 major testing strategies. You should have a very good understanding and should feel very comfortable with. Okay, and So what I can do next is really, let me take a little bit longer time before the last break and to quickly review the slides from this chapter. We can quickly summarize the things without going into the details, and then we'll take a break, and then I will do the exam review. Okay. So let me switch over to the PC here. Okay. And actually, I had the exam here, and so the boundary testing. Essentially, what we are trying to do is looking at the basic input domain boundary partition, and there's a simple domain analysis and testing based on the so-called EPC, extreme point combination. And then we were looking at two of the important boundary testing strategies, the weak n by 1 and the weak 1 by 1 strategy, and then looking at some other strategies. Okay, so essentially the reason for non-uniform partition testing is that we typically observe more problems around boundaries than inside your domain. So we need to do some boundary testing. Okay, so that's we talked about. Okay, and then essentially we try to test the input-output relations and try to look at the classification of the input space and then how it's processed. Okay, remember that whenever we talked about this boundary testing, here we said you received A processing, B processing. That's our oracle. You're supposed to be receiving A processing. You receive the B processing. Then we can tell that's a problem. Okay, so that's the basic assumption. We have a kind of a very much simplistic processing model. We say you have the boundary, and then your boundary will be within each of the partition, you will receive one kind of treatment or the processing or computation. Okay, and then we can use that to test the thing. Okay, and so it's called boundary testing, and sometimes it's because it's typically tightly linked to the input domain boundaries. We also sometimes call this the input domain testing. Okay, and so we can do this for numerical variables. For other string and other variables, it's probably not as applicable as numerical variables because we're talking about moving things a little bit and this kind of boundary and the things. It's typically they're dealing with the numerical variables. Okay, and the output of the is typically just used for problem for the result checking. We say you're supposed to receive A processing versus receive B processing. We can do that. Okay. And so we can define the variables in the space. We kind of talked about this earlier, talking about the input variables, input space, when we talk about something about test cases, test variables, and the things. Okay, so you are looking at an n-dimensional space of a number of input variables. Okay, and so a point is basically one with a specific value for each of these variables. Okay, and then we can look at these domains and subdomains that can be partitioned by some equations. Okay, and we most often deal with the linear equations. So basically, this function of f, x1, x2, and the things is a linear function like this. Okay, so it's a linear function like this. A1 x1 plus A2 x2 and so on equal to k. That's the boundary. You can say greater than equal to k, less than equal to k, greater than k, less than k, and things like that. That give you the defines your partitions. Okay, and then we look at the properties, whether it's open or closed. It's closed means that everything on the boundary belongs to you. It's open means that everything on the boundary not belonging to you. So whether you look at the inclusive of the boundary with respect to a domain or exclusive. So whenever you talk about open or closed, it's with respect to a specific domain, whether it's open or closed. Okay, and then we can look at the domain properties. It's closed domain is every boundary is closed. Open domain is every boundary is open. And then you may have some domains that on one side is open, another side is closed, and then on several of the side is open, so some other side is closed. So we have this mixed domain. Okay, and we have linear and nonlinear ones. Okay, so those are the terminologies that we kind of easy to understand, and then if you need to review them, you can read the book. Okay. With input domain partition testing is that you really analyze this problem, come up with a model, and then try to get the test point to test things. Okay, and in this case, is typically we use the graphical means to illustrate the test point instead of use algebraic ways to illustrate. Okay, of course you can use algebraic ways to illustrate the point. For example, over here I can give the x value and the y value for this point. So this one is the x1, y1, and this one x2, y2, and I can specify that by the x, y values. But most of the times it's easier and it's more straightforward to understand it, to look at the things by drawing things out. So you should be comfortable with the drawing things out. Okay. And then we can look at this boundaries and the domains and perform domain analysis. And so you can look at the domain analysis with each of the domain, what's the maximal, what's the minimal for each dimension, and look at whether it's open or closed, and you can plot them. Okay, so you come up with the strategies. But the problems with the domain partitions is basically there are two types of problems. One is ambiguity, one is contradiction. Ambiguity is that something is not defined. Contradiction is something that's defined by over-defined situation. Okay, so for example, if you have if you have a domain partition, let me go back to this example here. Let me see, I still have this one. Go back to this example. So the underdefined situation is, for example, that here, this boundary between A, B, and A, E, and AF doesn't belong to anyone. And you don't have that as a separate domain. Then if you have points on this here, it's not defined. Okay. And then the other case is that over-defined is that you say, for example, you say A is closed and B is closed. If you say both A and B is closed, then things on here belongs to A or belongs to B. You say belongs to A and belongs to B, and that's that's a contradiction. Okay. And in general terms is that if you think of this one, is that you may have some gaps in between, or you may have some overlaps in between. Okay, so that's the here between A and B. So if you have gaps, you have ambiguity. If you have overlaps, you have contradiction. Okay, and those kinds of problems, this ambiguity and the contradiction, most likely to occur around the boundaries. Okay, and then we can look at the specific manifestation of those kind of boundary problems. We can say there's a closure problem. You are supposed to be open. Now you are closed. You are supposed to be closed. You are open. That's a closure problem. You may have a boundary shift. Move the boundary this way or that way a little bit. You may have a boundary tilt problem. We look at those problems. Okay. And you may also have missing boundary and extra boundary. Well, we didn't discuss missing boundary and the extra boundary before, but actually missing boundary is easy, because if you have a missing boundary, that means everything on both sides of the boundary will receive the same processing, right? And if you have a missing boundary, then our strategy, weak one-by-one strategy, this on point and off point, or n by one strategy, they should receive different processing. If you have a missing boundary there, then they will receive the same processing because your boundary is missing. Everything belongs to the same domain. Okay, so the missing boundary is typically easy to detect if you have the boundary and the boundary is missing and your boundary point and your off point will be able to detect the problem. But when you have an extra boundary, well, it depends on where the extra boundary is. You may not be able to detect the problem. Okay, but that's the thing. No matter what you do, you may not be able to detect the problem unless you analyze the thing and try. You cannot really detect the problem by using the original boundary points. Okay, so for example, over here, if you have an extra boundary here, divided at B1 into B1 and B2, all those points, boundary points, will not detect this thing problem. To detect this problem, you have to analyze your extra boundary and find the problem. Okay, so we can look at when we analyze the problems, then analyze the different strategies. So we can look at the how can they detect this problem, that problem, and all kinds of different problems. Okay, and so what we come here is the next one is the extreme point combination. We kind of discussed this and the examples. So here I give you some extra examples. Extreme point combination works okay for this one. Really not working for this one. See, on this one we look at the kind of the cellular wireless communication towers, and they kind of have this hexagon layout and the things. And when you look at the minimal, maximal, minimal, maximal, so basically extreme point combination give you the bounding box and finding the corners of your bounding box. And it's not working for this one, and it's not working for this one, but it works to some degree for this one. Okay. Then we talked about the one by one, the N by one strategies. So N by one strategy, we talked about this one. N by one strategy, 2 on points and 1 off points. So we have the things closed on C1, C0 here. And then there's this illustration about the boundary tilt, how can you detect those problems, but you may not be able to detect the boundary tilt problem for the one by one strategy. So those are the discussions about those strategies. Okay, and the important thing is that try to have a good understanding of those strategies and try to do some more exercise, and so you can be comfortable with using those strategies to help you detect the problems. Okay. There are a little bit discussion about other BT strategy, boundary testing strategies. We call all those things weak strategies because we just have one set of points for each boundary. But sometimes the boundary between the two domains may be very complicated, okay, and may have some inconsistent closures and may have some other problems, okay, may have gaps in the boundary and things like that. In that case, then you might want to have multiple sets of points. That's when you have the so-called strong strategy, okay? So that instead of one set of for each segment, boundary segment, you have one set of points, okay? And so that's when you have some kind of closure change, gaps and things like that, inconsistencies on the boundaries, then you can use that strategy, okay? There's also the strategy with the nonlinear boundaries. With the nonlinear boundaries, one set of points may not be enough. Okay, so we did this circle before. Okay, and we can. That's one of the kind of typical nonlinear kind of boundary. You have a circle, or you have some other curves. Okay. When you have some other curves that we said, okay, with one set of points, let's say we do the n by 1 strategy. Okay, n by 1 strategy. We can say n by 1 strategy, we will be able to detect the boundary shift and the closure problem and those other things. But some of the boundary may be changed without, say for example, instead of this point, I have another circle, which is a much bigger circle, but still passing through those 2 points. That's possible, right? So because the 2 points doesn't define a circle. Okay, 2 points define a straight line on a 2-dimensional space. On a circle, 2 points doesn't define a circle, because when you have 2 points, you can have this kind of circle, have this circle, and you can even have this kind of circle. You can have many different circles that with that 2 points. Okay, and so if I have that one, then instead of this circle, I have this kind of circle. It's a bigger circle instead of a small circle. I cannot detect that kind of problem. Okay, so how do you detect that problem? Is that then you try to come up with additional points. Okay, instead of 2 points in a circle, if I have 3 points on the circle, then I can define a circle, right? And then in some cases, then I need 4 points or 5 points, so I can increase the number of on-points when I have nonlinear boundaries. Okay, that's one way to deal with this. And another way to deal with this, sometimes I don't know how exactly is my boundary. Well, how many points do I need to define this boundary? I don't know. It depends on the exact mathematical formula you have. Okay, and if it's a kind of polynomial of some n, the nth power and things, then you probably need in the 2-dimensional, you will need more than 2, maybe 3, 4, up to n of those different points. Okay, but then one easy way to do this is you can do some kind of linear approximation. See, I have this segments. I can do the linear approximation, and then for each segment, I have 1, 2 on off, or 1 on, 1 off, or something like that. I can do that. Okay, so for those kind of things, I can do so the nonlinear boundaries. I can do those kind of test. Okay, and let me try to wrap this up. Okay. And then there are also some extensions that, because the basic idea is that you look at the boundaries and look at the extending the boundary inside, outside boundary, and define where boundary ends. You can do this for data structure boundaries, do the other things, and you can do the vertex testing where 2 boundaries meet. Okay, the test the corners. Okay, and there are also extensions that for the queuing and for the actually I'm not going to talk about the queuing. We can skip that part. And we have also later on when we look at the loops, that there is a boundary point. In this case, it's not a boundary point in the input, but it's a boundary point in the number of iterations. A loop, typically you can go through it once, bypass the loop, go through it once, twice, and up to n times if you have an upper bound. And then we can use the boundary testing strategy ideas to test the loops as well. Okay, so this idea of boundaries and the boundary testing is important. We will be using it, revisit it later on, but for this part, the most important thing to remember is you need to be understand the basic concepts and the strategies. And the most important strategies here are the 1 by 1, the n by 1. And the EPC you should understand also, because that was one of the earliest strategy people proposed, and it's not really working well for some of the general situations. But unfortunately, there are still software tools out there help you do EPC strategies. And if you don't analyze their problem just blindly using the EPC strategy, it's probably going to waste you a lot of time instead of giving you a lot of confidence in terms of the correctness of your program. Okay, so let me stop there. I know I kind of went through this a little bit more quickly than I would like to, but I covered most of the important ideas in boundary testing and their details in their textbook. You can read it. And the thing is that textbook is static. Our lecture, and we can look at the things tilting and the things it's dynamic. It's easier to explain some of the things with the graphs and the things. So I hope that is good enough for you to have a basic understanding, and that you can read the book to get the details out of this. So let's take our second break, and we will have a short third segment. I will do the exam review. Okay, so let's take a 10-minute break for now.
Yeah, that's why I had this one. I didn't have lunch today. Yeah. It's just if you skip a meal or something, so it should be like, you know.
It's like a Monday, Tuesday.
So he's letting us know.
No, he's not there.
Oh, we have,
School will reopen on Wednesday.
so we don't have a Zoom call for the class.
Yeah, full prep is only on Monday and Tuesday. We would go to class on Monday and Tuesday. We got off.
So we still, so for
What
power,
was it is good?
so without in your power.
No, after this next week. Before commence exam.
But we still have,
The people who is class on Monday and Tuesday they got off. Those who go to class on Wednesday.
you should be able to give it off for check.
Okay, let's go back to our class and want to do a brief review for the exam. Okay, and so what I'm going to do is first I'm going to kind of talk about the different topics that we have covered so far and the type of questions that we have, and then looking at what kind of questions will be suitable for what kind of topic, and then I'm going to go over the sample midterm exam because several people had asked me to go over some of the things. I'll go over as much as I can. The parts that I cannot go over, I will try to post a kind of an answer key in the Blackboard. Okay, and so first that as you may have seen in the sample midterm exam, we have three types of questions. Okay, the first type is the multiple choice questions. Okay, and for the multiple choice questions, one of the important things to remember is that I ask you to pick the best answer for each of the questions, not a logically correct answer, because there might be several logically correct answers. Okay, so for example, if I ask you, what type of class this one is? Okay, this is CSE 7314, 5314. You may answer, it's a university class. Okay, that's the correct one. You may answer, this is a senior and graduate level class. That's a better one than the university class. It's a senior and graduate level class in software engineering. That's even better. So if you give it those three answers, then the one with the kind of with the most information, most relevant to the question is the one that you should pick. So in this case, it's this class. And another answer says this is a language class. Then which is kind of wrong. This is not a language class. So given those four answers, you should pick the what's that? The C that says this is a senior and a graduate level software engineering class. That's probably the best answer among the three. So remember that. So don't just pick the first one that appears to be right. You have to look at all the answers and then pick the best one. Okay, and then the second type of question is what I call the kind of definition discussion kind of questions. Okay, so usually ask you to define something, discuss something, compare something. So it's a kind of a short description kind of discussion kind of questions. So I call it a short answer kind of questions. Yes.
We need to write in the same paper which you will be providing, or we will have sheets?
You will have a sheet of paper. Yeah, that's the format. I talked about that before. Yeah, and no, you can have a sheet, but you should write your answer on the exam, official exam paper. And I have the one-sided. If necessary, you can write on the back side as well. Okay, but if you write on the back side, try to make a mark there. Turn over, or there's something more in the back side or something. Okay, and but typically I don't expect you need the back side to answer the question. Okay, but if you are not sure, you want to write more, fine with me. Okay, and so the short answer kind of questions is try to get to the point. I don't need beautiful, elaborative sentences. When I grade the things is I really looking for the keywords. Okay, if you have those keywords that cover the ideas, that's okay. So that's different from your project report. I'm not looking for your keywords and the bullet points. I'm looking for kind of written out text. Okay, but in the exam, you just use some bullets and the keywords. That's good enough. Okay, and then the third type of question is what I call the problem analysis and the problem solving questions. So typically, it's for some kind of testing. I give you a description of the thing, or I give you a program segment. Typically, if I give a program segment, it's going to be in pseudocode, so everyone should understand with the background in any language, any computer language, you should be able to understand. Okay, and then you need to come up with a model, and most likely I ask you to for the test cases. If I'm asking you boundary testing, you can draw some of those test points. So that's good enough. Okay. Later on, the test cases you probably have to stay out sketch out the test cases and so on. Okay, and so that's the three types of questions. Okay. Now what I want to do is to really also kind of we can look at the topics that we covered so far that map into those three types of questions. Okay. If you look at what we covered so far, we covered 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 13 through 16 to a certain degree. Okay, so if you look at those chapters, they are not equally important. Okay, some of the chapters are much more important than others. Okay. So it's kind of like our usage-based testing. Some of the functions are used much more often than others. If you want me to rank the chapters, 8 is probably the most important. Okay, 9 is quite important. So maybe if I put 3, and then maybe I have 2.5 stars here. Okay, and then it's probably chapter 3. Okay. And actually, when I say chapter 3, it's chapter 3 plus. So you kind of have 13 through 16 is covered here, and a little bit of 6 and 7 covered a little bit here. Okay, and then everything else is probably not as important as those other things, but you're supposed to know those as well. Okay, and then if you look at this one here, you have 3 testing techniques. Okay, so we have basically the partition test. Okay, and also the checklist. Okay, and then we have the boundary test, and we have their MUSA. Okay, MUSA OP, operational profile. Okay, so if you look at this here, this part really belongs to our problem solving. Questions. Okay, and then when you look at the rest of the things, then they are kind of fair game to multiple choice, and short answer kind of questions. Okay, so those two types of questions. And probably we'll have more things from here than from the rest of the chapters. Okay, so probably more things from here than from those other individual chapters. Okay, so that's a kind of a review. And of course, if you look at the topic 1 through 5 with the introduction, with 3 about QA. Yes?
So did you put chapter 13 to 16 in the category of chapter 3, or?
It's a kind of belongs to chapter 3. So we, when we did the chapter 3, we actually went beyond the chapter 3.
But
so like, 6, 7, 13 through 16, they are kind of covered
so it's
together.
going to be more like multiple choices, short answers, right?
Yeah. Because it's kind of hard to have problem-solving questions there. But you may, the short answer kind of comparison discussion, that's really good for the chapter 3 and the related material. Okay. Okay, so that's the kind of topic and the type of questions review. If you don't have any questions about this, I'm going to move on to the sample midterm. Okay, so let me move on to the sample midterm. The sample midterm, you all should have a copy. And so I don't expect you to read it from the screen, but because this is not typeset for the reading presentation either. Okay. So what I'm going to do here is that we have those 5 questions. So let me go from 5 back. Okay. And so that's the kind of we look at the problem solving once first, and then look back. Okay. The last question in the exam is the input domain boundary testing question. Okay. I can read this one a little bit, and we can discuss this one a little bit, but I don't expect you to read it on the screen. Students' coursework is divided into homework, midterm, final exam, and a project. That's exactly the weight assignment as we had in our class. Okay. A pass-fail grade is assigned depending on if 60% or above is achieved. Okay, draw or specify with numbers the test point for this problem with the EPC and the weak 1-by-1 strategy, and discuss their effectiveness. Okay, so let's work on this one. So let's identify. So the main thing here is really with the problem analysis. How do you analyze this kind of a problem and come up with your define your boundaries? So here the important thing is define your boundaries, define your domains, and then try to look at this. Okay. So when you look at this problem, you can look at the variables, and then look at the domains, and look at the boundaries. Domains and the boundaries. Okay. So with this one, you can see here is that we are assigning a pass-fail grade based on some thing. Okay. So the pass-fail will be the outcomes. Either you pass the course or fail the course, right? Okay. So if you get a 60 or above, you pass. You get less than 60, you fail. Okay. So if you think of here, you have the combined score. Okay, you have a total. If basically you can think of this one, you say, okay, if my total is 60, this is my total. If it's 60 or above, 60 to 100, or between 0 and 60, this is a fail. This is a pass. You say, oh, that's easy, I can do this. But that's kind of too simplistic. Because how do you get the total? Your total will be calculated by something else. If you do this, you get partial credit. Okay? Because if you think, oh, I don't know how to do this. I know that with the total I can do this. Then you can do this, do the boundary testing, and then you at least get some partial credit. Okay. Okay. So, but the thing is that now we are actually looking at the homework, exam, midterm, and the final, and the project. So you have homework, midterm, final, and the project. So you have this 4 part. Okay. So suppose what you have there is that they have this percentages and the things. Then you can make your assumptions about what's the grading scale and the things. It's up to you. The simplest assumption is that you say homework is up to 15 points. Okay. And then the exam is up to 25 points. Okay, so you already scaled. Okay, you can have everything with 100%, and then you will have to use a scaling factor. It's up to you. How do you want to model this one? So my way to model to simplify things is that I have this variable. So the range will be from 0 to 15, from 0 to 25, 0 to 25, and this one is 0 to 35. Okay. So if I assign score that way, then since it will be simple, then my total will equal to homework plus midterm plus final plus project. Okay. And if you want to use a 100% scale, that's fine. Okay. Everything 100% the scale, and then another way is that's fine. You work out the things yourself. Okay. But say this is what I use. Okay. So for example, if this is what I use, then now you have these things. And actually, when you do this, you have the extreme points, right? Each of the dimension you have what's the minimal, what's the max, right? Your minimal you can get is 0. We don't give negative numbers, okay? So minimal you can get is 0. Maximum you can get is 15, 25, 25, and 35. So when you do the EPC, what is going to be your EPC test point? So it will be under, minimal, max, over. You have to combine those things. So actually, in this case, I don't expect you to enumerate everything out because this is the 4 times the 4 times the 4 times the 4. Okay? It's how many? It's 16 and 256. So you have 256 points. Okay? And then I need you to give a few and then say how exactly you are going to do this. So for example, you have the under, you can use -1, over you can use 16 and 25 and 35 and so on and so forth. So you say you can have those combinations. So you have -1 for 1, -1, -1, -1. That's under. Okay, under, minimal, max, over, under. You can do this, and so you get 256 such points. You can state how do you get this, okay, and illustrate them by a few of the numbers, okay. And then you can also do the week 1-by-1 strategy. When you do the week 1-by-1 strategy, it will be, see here, this one has nothing to do with pass-fail. This one, because each of those has nothing to do with the pass-fail, because each of the things that you may be doing poorly in any one of those areas and still pass the course. And you may be doing perfectly in any one of those areas and fail the course. So this week 1-by-1 strategy is not working at all in this case. Okay, but when you look at the EPC strategy is not working at all. Okay, but if you look at the week 1-by-1 strategy, is that you have to look at this addition is greater than or equal to 60 or not. Okay, so you can pick a point. Okay, so you need one on and one off. So for example, I picked one on point. Someone say, oh, look at this one. I can pass this course without doing a project. Okay, so I can get something like I got 15 out of 15 from my homework. I got 20 out of 15 in my midterm, and 25 out of 15 in my final, and I got 0 in my project. Okay, well, I got 6 points. Okay, and so this one is on point, and then I need off point. Off point, then my off point will be, see, because this one is greater than or equal to, your off point need to be fail. This one is on point is a pass, and your off point need to fail. So I get, for example, that thing I can lower one of the grades a little bit, and something like that. I'll lower the off point is 14, 19, 24, and 0, for example. That's my off point. Okay, so in this case, or you can change one of those things, and or you can, if you can use half points or something like that, that's fine too. Okay, so that's a kind of the things that is expected. But this is actually this is a kind of like a 4-dimensional space. It's hard to draw the things. Most likely, I'll give you a 2-dimensional thing. And this one, say, for example, if you want to, you can do this as something that you can a simplified 2D dimension for the coursework made of exam and other at 50% each can reach up to 12 points. So if you want to simplify this to 2D, you can solve this. So we can modify this. So this is a kind of expected answer that you have. Okay, so this is a weak 1-by-1 strategy, is that looking at this total and then finding the sensitizations or individual variable values to make it select the on point and the off point. Okay, yeah.
So confused. How did you get the 256 points number?
Because each of the dimension,
Okay.
each of the variable, that's one dimension. You got 4 points. That one will need to be combined with the 4 points in every other dimension.
Okay.
And so it's a 4 point times 4 times 4 times 4. Okay. So 4 to the 4th power, that's 256.
Okay.
Yeah. Okay. 4 to the n power, and in this case, n is 4. Okay. Okay. The simplified solution is actually we can draw out. Okay. So I say, if you can say you have the exam and other. So you have those two parts. Okay. Exam is 0 to 50. And the homework and the project is 0 to 50. Then what we can draw is something like this. We can draw the exam, and then we can draw the other. Okay, so it's a 0, 50. This is a 50. This is a 50. Okay, so each of the things can be from 0 to 50. And then what is your total? Total is exam plus the other. Okay, so essentially you are looking at something like this here. Okay, so essentially what you have here is that you will have something over here. This is your pass region. This is your fail region. Okay, so this is your pass fail. What is this value here? This is 10, and this is 10. Okay, right? So 10 plus 50 is 60, and 10 plus 50 is 60, and so here that you have the perfect slope here. So you may have the 25 plus 30 plus 30 here, 25 plus 35, and things along this line here. So what you have here is that you have this. So this is your pass region. This is your fail region, right? And this one is shaded on this side. So whenever you are on the boundary, you pass. Okay. So what you have here is that then when you look at the 1-by-1 strategy, this is your on point. this is going to be our off point. Okay, because off point will have the different processing than the on point. So that's your pair of on-off weak one-by-one strategy for testing this. Okay. And what's your extreme point combination? Extreme point combination, when you pass, okay, when you fail, this is the minimal here, maximum here, right? And so with your EPC, essentially for this region is that you have those and those. And for the path region, is actually the minimal is here, max is here, minimal is here, max is here. So you get those. That's so. This is for the path. Actually, I should use different color. So for the path is those 4 corners. For the fail is those 4 corners. And you can see here, this extreme point combination is really not testing, not really working well for this situation, because all those things are passes and all those things are fails, and then you're testing some of the corners, but you are not really doing a good job testing the boundaries between the pass and the fail. Okay, so that's their boundary testing problem. So if you give the 2D problem, if you analyze the thing and you can reduce it to 2D, it's typically easier to draw it on the on a picture. Okay, and if it's higher dimensions, then you have to kind of use the algebraic, because we typically cannot really draw 4 dimensions and over that easily. Okay, and 3 dimensions you can still draw the 3-dimensional projection on the 2-dimensional. It's still hard to draw, but the 2D, 1D you can draw, and higher dimensions you use their numbers to specify things. Okay, so that's the boundary testing one. Okay, so let's go back. Coverage and usage testing. Okay, this question is in Blackboard, instructors review, post, update, delete course material, and evaluate submit work by students. Students review course material and do these things. Build your OP for this using either Musa 1 or Musa 2, and discuss how you would collect the required information. Okay, so to me, this remember that the Musa 1 and Musa 2, Musa 1, you can use either one of them. That's fine. Okay, it's up to you. But to me, this one looks like a little bit more like a Musa 1 kind of thing. So when you have different have customers, different users, and then you can look at their operations, and then you come up with the operational profile. Okay. And some people say, I want to use Musa 2 and say I kind of have a tree structure. That's okay too. It's up to you. And then you can look at the basically their different operations can be divided by the different user types and their individual operations and so on. So it's up to you whether you want to use Musa 1 or Musa 2. Okay, but this one should be so if you use Musa 1, okay, so for example that, then you need to look at their customer profile, and in this case it's just one profile. There's nothing, okay, you can skip, okay, and then you have the user profile, and then you have the thing, user profile. What you have the instructors. And you have the, what else? What do we have? Students and admin, and then 3 types. So you have to collect the information. So you can make up something that you say, I collect the information. Instructor makes up 10%, and the student make up 80%, 85%. Okay, so the 95 and then admin 5% or something like that.
So I just assign the numbers?
Yeah. You say you can collect those numbers because I asked you to discuss this a little bit, okay? And then you can look at the system mode, and then here that you probably is not really relevant, and then you can look at the individual things, and then so how many things this one use, and how many things this one use, how many things this one use in operations, and then you map out and then get the operation list and the things. So for example, you have something like operations here, you have a profile. For example, you have something like 0.5, 0.1, 0.1, 0.05, and something like that. You make up some numbers, and then you weigh them, and then you get this final operational profile. Okay. Yes?
What do those numbers on the right represent?
Those ones? Oh, those ones, you collect the information for the instructors, how often they use this operation, this operation, this operation, this operation.
Like viewing and
Yeah. It's kind of like the individual operational profiles for instructors, for students, for admin, and then you need to combine them, such as we did with combining the customers, then into the user profiles, into this your final operational profile. Okay, so that would be my way of solving this kind of a thing. If you have some other ways, that you are welcome to do so, and as long as it makes sense, you'll get at least some partial credit. Yes?
Is there any way we can get the sample answers for this midterm test so that we can see what?
That's the sample.
No. Like, well, we're not gonna go through all of them, are you?
Yeah. I'm going. The ones I do not go through, I will post something.
Okay.
Yeah. Okay. So this is this one. Yeah.
How would you just go over like how would you do this in a tree structure?
This one you probably you can do something like that user type, and so it is admin, and then some like for example that the operation can be dependent on the type of people you have, and so you have admin here, and you have a student, and you have an instructor here, and then you have some other things, and so you can work out this kind of thing. Actually, quite a few people did this, and they received full credit. Okay. Yeah. So it's up to you. This one looks to me is that MISO 1, to me personally, MISO 1 seems to be okay. But if you want to use MISO 2, as long as it makes sense, that's fine too. Okay. Next one, let me go back to the picture. The one is among the testing techniques, PT, BT, and the UBST with MISO OP. Which one is more likely to help us achieve reliability goals, while what goals the other two can help us achieve? Okay. So this one is actually quite straightforward, because UBST is really help us with the reliability. The other things are help us with the coverage. Okay. So you basically discuss that. UBST is you look at the reliability. What's the reliability definition, and based on the definition and the use UBST that covers whatever customer uses the most, and so that has the most influence on reliability. So that help us achieve reliability goals. So that kind of a discussion. Okay. And then the second part, how would you construct the model for white box partition testing? Can it be automated? What about the black box partition test? So that's a kind of a description, the white box partition test. So essentially, that's what your homework you did. Homework you, I think most people did the white box. So some people did a black box. So white box partition test is basically you analyze the code, go through the code, and look at the decisions. Okay, and then you use the decisions to partition things out. Okay, and can it be automated? Maybe a little bit, not too much. Okay, and so black box, then you essentially you analyze their implicit decisions in their specification or the description, and then try to come up with the thing. So you basically you have to describe how do you do this, and so as long as you make your idea clear and your idea makes sense, you will get most of the point here. Okay. If you want to use the examples, that would be good too. Yeah. And then back to this one. There are some questions. The formal method is equal to formalizing inspection, true or false. Actually, people answer both true and false and get the points. So it's okay. For those kind of things, I really looking for the argument you have put behind it. Okay, and so I would tend to say this is true. It's kind of formalized to a degree that you kind of instead of just looking, examining, analyzing, you are really trying to use mathematical, logical reasoning with your inspection. So that's my reason. But if you say it's not the case, then you can talk about emphasize the differences. That's okay too. Okay, and testing is the verification or validation. It's both. Yeah. So and then you give examples about why it's both. Okay, and give example to illustrate how fault tolerance works and achieves the goal. And we talked about the example of MVP and the recovery block. So if you give one of those examples, that would be good. Okay. So I don't have time for the multiple choice, and so I will post the answers to multiple choice in the Blackboard. Okay. Yeah. Sorry, we're running out of time, and but I will be posting the multiple choice questions to the Blackboard. And okay, that's it for today, and good luck with your exam next week. Okay.
Constructing the model for.
Let me put this up first, and okay. Yeah.
Constructing the model for bypass testing and black box testing, do you actually want to write the test cases or something?
No, just the model. Yeah.